quiz tomorrow is so basic and straightforward, all right? It's 4 questions. The reason it's 4 questions is because some of these take a lot of work. So you'll get partial credit throughout. You'll have 1 Kramer's rule, that's a 2 by 2. You'll have 1 Kramer's, that's a 3 by 3. Then you'll have 2 partial fraction decompositions. One where all you do is set it up, and the other one that you have to go through the whole thing to solve. So I'll do a couple of these. I'm not doing all of them because they get redundant, but let's look at number 1. How do you solve using Kramer's rule? What do we do? What do you have to find? What do you find first? The determinant. You got to find the determinant, whatever the determinant value is of the coefficients. Then you have to find the d sub x. Then you have to find the d sub y. Okay, so how do we do that? With a 2 by 2, you just write out the coefficients of x and y. What are the coefficients of x and y? Coefficients of the numbers in front of the letters, guys. Come on. Okay, so -5, -2, and then what are the coefficients of y? 5 and 2. All right. So how do you find the determinant of a 2 by 2? It's just a times c. So -5 times 2 minus b times d. So 5 times -2. What's -5 times 2? -10. Minus, what's 5 times -2? -10. And then what's -10 plus 10? 0, okay? What happens, guys, when your initial determinant is 0? Because think about, how do we find our answers to our question? You take whatever your d sub x is and put it over your determinant. Whatever your d sub y is, you put it over your determinant. Can you divide by 0? So what's your answer here? No solution. Whenever you work out a Kramer's rule problem and you get the initial determinant, which is just the coefficient matrix, to be 0, then you already know it's no solution. Now you could check using like substitution or elimination, whatever, but you can see that there's no solution. So you would do the same thing with number 2. Let's go ahead and do number 3. I'm probably not going to work the whole thing out because it's long. But what do we have to do for number 3? You have to find the determinant of the coefficients. Then what else do we find? D sub x, D sub y, and D sub z. Whatever letter you're looking for, like D sub x, how is that different from finding the initial determinant? What do you put in the column for x's? The answers. If we find D sub y, what do you put in the column for the y's? The answers. If you're finding D sub z, that's how you find. So let's find the determinant for this. First of all, if a letter is not represented, what do we use? 0. Okay, good. So write your first column. What are my x's? 3. I'm on number 3, right? So 3, 1, and 9. All right, what are my y's? What are the coefficients of my y's? 6, 1, and, okay. And then what are my z's? 0, -1, and 15, okay? Somebody asked if you can, like, look at this last one. If you could divide everything by the same number, could you simplify it? Yes. Can you divide everything by the same number here? No, right? Somebody was, what, it looks like 3. Does 3 go into 28? No, so you can't do that. But if you can, on both sides of the equation, go ahead. So how do we find the determinant for a 3 by 3? I can't just multiply yet. What do I have to do? I have to recopy the first 2. So I have 3, 1, 9, and then 6, 1, -12. So now this is where we do our major and our minor, correct? So top left, bottom right. That's my major. So I'm going to do major first. What's 3 times 1 times 15? 3 times 1 times 15. 45, okay. 6 times -1 times 9. -54, right? And then 0 times 1 times negative 12. Plus 0, okay? Now it's minus. Now I'm going to do the minors. So that's here, here, and here. All right, what's 9 times 1 times 0? 0. What is negative 12 times negative 1 times 3?
36.
Yep. And then what is 15 times 6? What is it? 15 times 6? Yep. So then I have... And now we just have some basic math, guys. What's 45 minus 54? Negative 9 plus 0 would be negative 9. Minus, what's 36 plus 90? What's 36 plus 90? 126, okay. So you have negative 9 minus 126 gives you what? So your determinant is negative 135, right? So now that we found our determinant, negative 135, where is that going to go? When I find all of my D subs, where is the negative 135 going to go? In the numerator or the denominator? It's the denominator. It's what you divide by. So negative 135, negative 135, negative 135. All right, so now I'll do D sub x, and then I'm not going to do the rest of them because it's just redundant. But how do I do D sub x? What do? Do I write down my x's? I put the answers in the x column because that's what I'm trying to find. So I'm going to write negative 4, negative 2, and 28, correct? Now I write my y's. What are my y's? What are the coefficients of y? 6, 1, and negative 12. What are the coefficients of z's? 0, negative 1, and 15, okay? Since we're looking for D sub x, you put the answers in the x column. When you're looking for D sub y, you put the answers in the y column. So before I can find this determinant, I have to do what? I have to recopy what? The first two. Good. So negative 4, negative 2, 28. Aren't you guys so glad we didn't quiz today? That would have been a disaster. So then I have 6, 1, and negative 12. So now let's find our three majors. Top left, bottom right. There's 1, 2, 3. You guys are more than welcome to use my color pencils. So what's negative 4 times 1 times 15? Negative 60. Use your calculators, guys. What's 6 times negative 1 times 28? 168? You said? Okay. So negative 168. And then what's 0 times whatever? 0, okay? So now that's a minus sign in the middle. And now let's find our minors. So 1, 2, 3. What's 28 times 1 times 0? 0. What's negative 12 times negative 1? 12 times negative 4 is negative 48. And then what's 15 times negative 2? It's okay. Negative 30 times 6. Negative 180, okay. So now let's simplify. What's negative 60 minus 168? Negative 60 minus 168. Guys, somebody do it. Don't just sit there and stare for somebody else to do it. Negative 228, okay. Minus, what's negative 48 minus 186? Or 180? Negative 228, okay. So what's negative 228 minus a negative? That becomes a positive, right? So what does this equal? 0. So I go up here and I say this would be 0. What is my x value for this set of your ordered triple? 0. Your x value is 0. Is it okay to have 0 in the numerator? Yes. Is it okay to have 0 in the denominator? No. The biggest thing you guys have to do is just stay organized and check. Recheck and check and check and recheck again to make sure you guys didn't miss a sign or something like that. This is not super hard. It's just a pain in the butt. You know, we can't give you 4 of these. It would take you 2 hours to do. So just take your time. You know, if you get really weird numbers like negative 117 over 433, probably made a mistake. Right? If there's a fraction tomorrow, it'll be a simple one. 3 over 2, 4/5, something like that. Yeah.
There's 2 of this one?
There's 1 3 by 3.
Okay.
There's 1 2 by 2, like the first one. All right, then we're going to go to partial fraction decomposition. Do you guys see the difference between number 5, where it says write the partial fraction decomposition, and what? Do not solve. All you have to do is set this up. So what is my first step? Factor. What can I factor the bottom here to? What times what gives me negative 70 when I multiply, but a positive 7 when I add? Oh, Lord. Negative 70 when I multiply, but a positive 7 when I add. How about 10 and 7 and 7? Does that work? Or no? Has anyone returned from the spring break? What about if I change this to a 3? We're not going to give you any that don't factor, I promise. How about now? Okay. We're not going to give you any that don't factor. That was mean to make you think a little bit right now. My bad. All right, so how do I set this up? All I have to do is set this up. So I'm going to put an equal sign. How many different fractions do I have? 2, because I have 2 different binomials in my denominator. Does it matter where I put the x plus 10 and where I put the x minus 7? Does it matter if one goes first, one goes second? No. So I'm just going to write here x plus 10, and over here I'm going to write x minus 7. What goes in my numerators? What goes in my numerators? A and B. That's all you have to do when it says do not solve. Factor the denominator, set it up. Say you had 3 different things in your denominator. How many fractions would you have? 3, A, B, and C. Okay, good. I'll do 6. 7's like the exact same. Let's do 6. Just says to set it up. We don't have to solve it. So what do I look at with the denominator? I'm going to factor, okay? Factor this for me. Okay, take out a 3x. And what are you left with? X squared plus 9. Does that factor more? No. If it was a minus, good. If it was a minus, what would it factor to? X plus 3x minus 3. You'd have 3 pieces. This does not factor more. Don't make up new math. How many denominators do I have here? I have 2. I have 3x, and I have x squared plus 9. If it was a minus sign, guys, if it was x squared minus 9, you'd have 3 fractions. You'd have 3x, x plus 3x minus 3. But it doesn't. It doesn't factor. Don't create new math. So what goes in my numerator? A and B. Perfect. Some of us might need to look at some factoring. All right. 8's a long one. All right, let's work 7 out, and then we'll set up the other ones, and then you guys can work them out if you want to. This says write the partial. Oh, no, this says do not solve. All right, these say solve, right? These are both long. Let's do 9. Let's set this one up. What would this become? What can I factor out of the denominator here? Okay, an x, then I'm left with x squared minus 100. So that becomes what? X times x plus 10 and x minus 10. So how many different fractions do I have here? 3. All right, so if this was a solving one, which it is, I'm just going to set up how you would solve it, but I'm not going to do the whole thing. I'll solve the last one. So I have x here plus b over x plus 10. And then I have plus c over x minus 10. Now, how do we go about solving? What would I have to do? What do I have to look at? I have to say, okay, A has the x. What is it missing? X plus 10 and the x minus 10. B has the x plus 10. What is it missing? From the other denominators, what is it missing? The x and an x minus 10. C has x minus 10. What is it missing? X and x plus 10. Then you would now say to yourself, oh, okay, now the left-hand side looks the same as the right. So you would take this and evaluate it how many different times? 3 times. What are the 3 numbers that you're going to use to evaluate? X equals 0, x equals negative 10, x equals positive 10. When you evaluate, what should happen each time? When you plug in 0, how many variables should cancel out? 2. When you plug in negative 10, how many variables should cancel out? 2. When you plug in positive 10, how many variables should cancel out? Every time you guys go to solve, there should always be only be one variable, and then you say, okay, that's my A, that's my B, that's my C. This one's just long. I'm just not going to work it out. Let's do this last one. Okay, let's see if we remember how to factor. What's 3 times 14? 42. Okay. Are there factors of 42 that multiply to give you 42, but add or subtract to give you a negative 13? 6 and 7, okay? Remember, guys, your A term is not 1. So you can either do it the grouping method or the way that I do it. I would write it out as x minus 6 and x minus 7, right? What do I have to do with that 3, though? I have to divide both factors by the 3. Does 6 divide by 3 pretty? Yes. So my one denominator is x minus 2. My other denominator is 3x minus 7, okay? Those are my 2 denominators that I'm going to have for my A and my B. Everybody with me? Go ahead now and tell yourself, what are the 2 numbers you're going to use to evaluate? If you were to set each parenthesis equal to 0, what are the 2 numbers you're going to use to evaluate? X equals 2 and x equals 7 over 3. All right, our fractions are our most favorite thing to work with? No, but you guys might have them. So let's set up our partial fraction decomposition and then solve it. So I have A over x minus 2. If you want to put the other one first, you can. Plus B over 3x minus 7. Now, before I can say negative x plus 7 on the left side equals the stuff on the right, I have to make equivalent fractions. So I look at my A. My A has an x minus 2. What does it need? The 3x minus 7. My B has the 3x minus 7. What is it missing? X minus 2. Now you can say that the left-hand side is equivalent to the right, and you can solve. So now we just write down the equation, and we solve it twice. We have negative x plus 7 equals A times 3x minus 7 plus B times x minus 2. And we're going to solve this 2 times. And what are we using? What 2 numbers are we going to use? We're going to evaluate where x equals 2, and we're going to evaluate where x equals 7 over 3. I'm going to do the 2 first because that's easier, right? So I'm going to plug in negative 2 plus 7. I need to give myself more room. Negative 2 plus 7 equals A times 3 times negative 2 minus 7 plus B times 2 minus 2. What's going to happen there? Well, isn't that, there's a negative though right there in the problem, no?
No, like the 3 times.
Oh, my bad. Thanks. Right there. Thank you. What happens with my B? What's 2 minus 2? 0. So this is going to cancel. Every single time you do this, guys, every variable should cancel except for 1 because you're just solving for that 1. So what's negative 2 on the left-hand side? What's negative 2 plus 7? What's negative 2 plus 7? 5. Thank you. Equals. All right, let's evaluate. 3 times 2 is 6, and 6 minus 7 is? Negative 1. Okay. You divide both sides by negative 1. So A equals negative 5. Everybody okay with that? Okay, that's one part of my answer. Now the other one's not going to be as pretty. Just relax. You guys will be all right. We have to evaluate now using what? 7 over 3, a fraction. Okay, so I'm going to say negative 7 over 3 plus 7 equals A times 3 times 7 over 3 minus 7 plus B times 7 over 3 minus 2. All right, so first thing I'm going to do is we're going to have to talk about common denominators and stuff. What's a common denominator, guys, between 1 and 3? 3. So if I multiply the bottom here by 3, then I have to multiply the top by 3, correct? What's 7 times 3? 21. So this becomes 21. So what's negative 7 plus 21? Okay, so 14 over 3. Perfect. Equals. Let's go ahead and work this out. If I multiply 3 over 1 times 7 over 3, what happens to 3's here? They cancel, right? So I have 7 minus 7, which is 0. So that cancels out. Perfect. So then you have B times, common denominator again, between 3 and 1. 3. So if I multiply the bottom by 3, multiply the top. What's 2 times 3? 6. What's 7 minus 6? 1/3. Okay. So now we're solving for B. If I'm going to solve, I need to divide both sides by 1/3, right? So the same as multiplying by 3 over 1. You guys agree? Okay, so I can multiply here by 3 over 1, multiply here by 3 over 1. So what is your B term? 14. What do I do with those two things? I found out A was negative 5, and I found out B was 14. What do I do with that? I'm going to put it back in. I'm going to go back up here to where I set it up, and I'm going to say, okay, my A term is negative 5 over x minus 2. And then I have plus, my B term is 14 over 3x minus 7. And that's your partial fraction decomposition. What were to happen, guys? Say you got your A term was negative 5 over 2. It's not, but just say it is. How would I write my answer? I would have negative 5 over 2 times x minus 2. Don't leave a fraction in the numerator. Just put the numerator in the numerator, put the denominator in the denominator. This is not the case here. I'm just saying if you were to get a fraction. But the reason we can't give you 10 of these is because you don't have the entire day to take the quiz. It's a very tedious process, but nothing you guys can't handle. You guys all right? Yes? All right, before your next test, we have one more thing to do. So between now and May 7th, we have one more thing to do. We're almost there. You guys are doing good.